I welcome you all to the next lecture in EEE 615 Microcontroller Architecture and Organization. In continuation to the KEIL video lecture, what we saw last time, I'm going to introduce you to few more assembly instruction set, especially things like how to create a loop in assembly language, how to fetch from memory, how to write back to memory, how to get the data from the code memory, how to write the data in the code memory itself. Okay, so please listen carefully. This will be very useful for Friday's lab. The first instruction set that I'm going to introduce you to is CJNE. This is nothing but compare and jump if the two values are not equal. That is, you have a quantity or a data in R1 and you have another quantity or data in A. I told you 8051 is an accumulator based architecture, so accumulator should be one of the operand. So what it will do is it will compare the contents of A and the register R1, and on comparison it will jump to the location specified by the user if they are not equal. In a sense, how the flow is, I will write CJNE, that is compare and jump if not equal A comma R1 comma, I'll give the jumping location, say loop 1. Then I'll write so many commands, then loop 1, I'll write other function. So what will happen is it will compare A, it will compare R1. If they are not equal, it will jump only if they are not equal to the location loop 1 specified by me and execute these instructions. These instructions will not be executed. On the other hand, by chance if they are equal, it will not jump to this location, it will continue doing the execution that follow this instruction. Is that clear? Understood? So this is CJNE, compare, jump, and if not equal. The next instruction that I'm going to let you know is DJNZ. This is decrement and jump to the user specified location if the decremented number is not equal to 0. For example, if I say move R1 comma 8, hash 8h, and then DJNZ R1. Okay, whenever this particular statement is executed, it will keep on decrementing R1. So 8 will become 7. Once it is decremented, it will be checked whether it is equal to 0 or not. In this case, it is not equal to 0. So what I can do is I have to make it jump to a location. Let's say here. So I'll say here. So what will happen? Since it is not equal to 0, it will go back here. Again, in the next step, it will be decremented to 6. 6 again is not equal to 0. So again, it will jump here. You get the idea, right? So till that, ultimately it will come to 1. Again, this will not be equal to 0. So again, it will jump back to this location specified here. And the next step, it becomes 0. Now in this case, 0 equal to 0. So instead of jumping back to this location, it will start executing the steps next to it. Now, it is not necessary it has to jump to the same location. It can also jump to a different location. This is just an example that I am writing here to teach you what will happen. So the DJNZ is nothing but it will take a quantity or a data, okay, say R1. In this case, the rule that accumulator should be one of the operand does not apply. Okay, it could be a register or it could be even an accumulator. So it decrements the value and then it will jump to the user specified location only if the decremented value is not equal to 0. If it is equal to 0, instead of jumping to the user specified location, it will come to the next. Okay. The next instruction that I'm going to teach you is called JNB. This is nothing but jump on bit, jump on no bit. Okay, what is this jump on bit, jump on no bit? Especially when it comes to timers, or let's say carry flags, or just flags F0 and F1. This command JNB, it can be used either as a positive logic or a negative logic. So what you can do is you can simply say JB loop 1. So depending upon the context, if one of these parameters are set to 1, timer flags or carry flags or the general flags F0 and F1 are set to 1, it will jump to the specified location. JNB loop 1 means it will jump to loop 1 when it is not set. So this will jump when the bit is set. This will jump when the bit is not set. So this is JNB. So this is the next set of instruction. Next I'm going to talk about is DPTR. This is nothing but data pointer command to fetch data from memory. I should say data memory, because 8051 is Harvard architecture, so you have program memory and data memory set separately. So to fetch data from data memory or to write data to the data memory. Now this can also be used to fetch data from code memory. I will tell you how. Okay, the command that you will be using is move C A comma at A plus DPTR. This is the command you will use to fetch data from the code memory. Now to fetch data from the memory, you have to use move X A comma at A plus DPTR. Now this memory what I am talking about is purely external. It's purely external memory, not internal data memory. So to fetch data from external data memory or write data to the external data memory, we use DPTR, or we can also use DPTR to fetch data from code memory, that is read data from code memory, we can use DPTR. All these instructions plus how to create a loop using generic delay will be taught in the KEIL. Okay, first I'm going to teach you how to create a general delay loop. Or first let me tell you how to create a loop in assembly language programming. So this is KEIL. You know how to open a project, how to create a executable an ASM assembly level file, how to add it to the group. So assuming that you have practiced and you know it very well, I'm continuing with the program. As usual, I'm writing 0000H. So this is the origin I'm starting from. Okay, I say move A comma hash 5H. Okay, move R1 comma hash 6H. Okay, or I don't even need this increment. INC is a command called increment. Similarly for decrement you have DEC. So increment A. Now I want to keep on incrementing A. Okay, so what I simply do is, I've already introduced you the function sjump. I am asking the program execution to unconditionally jump. sjump, ajump, ljump, they are all unconditional jump. Okay, whereas the CJNE, DJNZ, JB, JNB, they are all conditional jumps. So sjump back. Back is the label name or the loop name I'm giving where it has to go. So I'm writing back here. Okay, so sjump back. So invariably this is going to be in a infinite loop. Okay, now I'm assembling it. I get 0 error 0 warning, so I'm going to the execution mode. Now you see what happens. First A gets 5, okay, then I increment A, so A gets 6. When it comes to S jump back, see what happens, it goes to back. So now no matter how many times I'm going to press run, it's going to keep on jumping back, and A is going to keep on getting incremented. You see that? So this is how you create a loop. So simply you give a jump statement, a label where it has to jump. This is nothing but actually the address. Okay, this is the address. See, when I keep on that, it gives me the address where exactly this back is located. So this is where it is going to jump. Okay, you get it? You understood? So no matter how many times I press, you see it is going back again and again. So this is how you create a simple loop. Now this is an infinite loop. What if I want to make a finite loop? Very simple. What do I have to do here is simply add a statement, move r1 comma, say let's say we want to increment it 10 times, or say 8 times. So I say 8h. Okay, I move that. Now increment A. Now I'm going to make a small change here. If you see, what I'm going to do is I'm going to make use of the statement DJNEZ, decrement jump on no zero. So I'm going to say DJNEZ. I want to decrement R1 because R1 is my counter. R1 is my counter. So decrement jump on no zero. Where do you have to jump? So I want to increment it 8 times. So as long as 8 is not equal to 0, I want it to jump to back. Okay. Once it becomes 0, move A comma, R2 comma A. So I'm moving the content from A to R2. You get it? So the logic is 5 will be incremented 8 times. Okay, so till it is 8 times, it will keep on rotating in this loop. Once it is over 8 times, I'm moving the content of A to R2. Let's see how this works. As usual, I've assembled it. I'm going into this. So first step, you see A is getting 5. Next step, you see R1 got 8. Okay, then it is incremented to 1. Now, if you please concentrate on the value of R1, from 8 it has decremented to 7 because of DJNEZ. Now 7 is not equal to 0, so it will again shifting to back, it will increment A. Now go again, carefully look at the value of R1, it becomes 6. So every time it runs in the loop, it is decremented by once. Again A becomes 8, again R1 becomes 5, A becomes 9, R1 becomes 4, A becomes decimal 10 or hexadecimal A, 3, 2, 1. Okay, it becomes D. Now at this particular point, the 1 will become 0. Okay, now when it is comparing the DJNEZ, so it has decremented it to 0. So now the value of R1 is equal to 0. So instead of going to back, if you see, it has come to move R2 comma A. It didn't go to back like previous attempts. It came to move R2 comma A. So when I do this, you get, see, the accumulator value 0D is copied to R2 and the program ends there. You get it? This is how you create a simple finite loop. Simple finite loop. Okay, now remember I was talking about memory operations to you. I'm going to tell you how to work on the memory operation using indirect addressing. Now the memory operation, what I'm going to perform is in the internal data memory. Okay, so what I'm going to do is I'm going to store data in the data memory starting from 30H. Starting from 30H. Okay, so first I'm going to move R0 comma hash 30H. So this is going to be my address from where the data starts, but it is going to be considered as a data as far as R0 is concerned. Now what I'm going to do is move A comma at R0. So by putting at, what am I telling the processor? That the data what R0 has is no more a data, it is the address where the data is. Okay, move A comma R0, INC R0. I'm incrementing R0 so that it can go to the next memory location, and I'm simply going to say end. It's a very simple program. So I've compiled, it gives me 0 errors, 0 warnings. Now, okay, I'm going to go into the debug. You can view the memory window, you can write on the memory window only in the run session or the debug session. So please remember that. So I'm going into the debug mode. Once I go into the debug mode, I have to look at the memory window. So I go to memory window, I want to look at memory 1. So this is memory 1. Now, what did I say? I'm going to start storing data in the data memory of the 8051 starting from the address 30H. Okay, so to get to that particular data memory address in the memory window, this is the memory window, what address do I have to type? D colon, because D stands for data, C stands for code. I'm going to store it in data memory. So I say D colon 30H and press enter. Now you see 30, 40, 50, 60, this is the data memory. So how do I input the data into the memory? I simply double click on the location 1, 2, 3, 4, 5, 6, 7, 8. So I've simply randomly input 8 numbers into the memory starting from 30H. Now you see the accumulator content is 0. So as I proceed, see what happens. First time when I run, R0 gets 30, the data. Okay. Now at this point of time, what the processor will understand is, to the accumulator, it has to move what is the address that is there in R0. The address that is there in R0 is 30. So whatever is there in location 30 will be moved to the accumulator. So ultimately what you should see now is the 01 being moved to the accumulator. You see, 1 has been moved here. Now next time I'm incrementing R0. So what will be the value of R0? 31. Next memory location. So it has incremented. See, R0 has become 31. Now what is in location 31? The number 2. So now number 2, when the statement is executed now, number 2 will be moved to the accumulator. You should see the 01 changing to 02. Okay, we have made a small mistake here. What is that? I have to come out of debugging mode. I haven't given any jump statement. I am not going back. Got it? So I say S jump back. I'll go here and I will say back, save, rebuild, go back to the debugging mode. Now please remember one more thing. It's good that this error happened. The problem, one of the things that you should remember is, if you just go back to see your memory window again, every data would have been erased. That is, it will not retain your data what you have entered. So luckily for us, it is still there in 30H. Again, we have to re-enter the data. There you go. I have re-entered the data. Now let me run step by step. So R0 has got 30, and the moment it happened, it is 1 which is there on 30 has been moved to the accumulator. Now R0 has become 31. The data that is there on the address location 31, that is value number 2, will now be moved to the accumulator. Now you can see the 1 changing to 2. Similarly, as I run, 31 becomes 32. So now it will become 3, 4, 5. You see, it is reading one by one the data from the memory. Now the problem here is, again, this jump what we have given is unconditional. We know that it has to stop reading after it reaches this point. Okay, it should not read beyond this point, but the processor doesn't know. So as I run, if you see, it keeps shifting. We don't want that to happen. So what do? There is a simple way to do it. Again, introduce a condition. How will you introduce a condition? Very simple. Move R1 comma hash. Just specify the number of locations you wanted to read from. Let me say 8H. Okay. So instead of simply giving sjump back, you say DJNEZ R1 comma back. So save, compile, go to the debug, again view memory windows. Already it's open. So again I'm entering the data at 30H, 2, 3, 4, 5, 6, 7, 8. Let me give some data here so that you'll be able to identify. I'll give 10, 11, 12. So as per instruction, it should stop here. Now let's see what's happening. So R0 gets 30, A accumulator gets 1, the first location. Now R0 is incremented to 31. R1 is decremented to 7 because of DJNEZ. It's not equal to 0, so it's going back to, see, observe the values changing. So now it has become 0, so it won't go back to back, but it will end. See, no matter how many times I run, it will not read beyond 8. It stops there. It doesn't read 10, 11 or 12. Now if I remove this DJNEZ and put an unconditional jump, it will read no matter what junk value it has got. Understood? Clear? How to put a conditional statement, make it run. Okay. Now I taught you how to read from a memory. Now I'll teach you how to write from a memory. Okay. So in this section, what am I going to do is hash 40H. So this is the address location from which I'm going to read data, and this is the address location to which I'm going to write the data. Okay. So move A comma at R0, increment R0. After this, I'm going to say move at R1 comma A. So this is the destination, this is the source, and I'm going to say increment R1. Okay. Now we need the counter. Move R2 comma hash 8H, decrement R2. Okay, so what the logic is, this is the address location where I want to read the data. This is the starting address location from which I want to write the data. This is the counter value. So first what I'm doing is I'm reading the data from the first address location, writing it to A. Then I'm incrementing R0. Then whatever is in A, I'm writing it back to the memory. Then I'm incrementing R1 so that it doesn't write it in the same location. If I don't write this increment R1, it will keep on writing on the same location. Okay, if you want, let's comment this and see what happens, then you will be able to understand. Going into the debugging mode, I see the memory window here. Okay, so 30H, I'll write 1, 2, 3, 4, 5, 6, 7, 8. Now it's better you open another memory window so that you can see the output as well. So I go to view, memory window, I say memory window 2. Now another memory window appears here. So from where do I want to write the new data? 40H, right? So I'll say D40H. So this changes to 40. Okay. Now let me run, see what happens. So as usual, R0 gets 30, R1 gets 40, R2 gets 8. So this is my one data location, this is another data location, and this is the counter value. Okay. Now you see accumulator got 1. Okay, it has reduced to 30, it has increased to 31. Now you go to memory 2, you see at 40 what's going to happen. See, it has written the value 0, 1. Okay, you get it? So this is how we write to the memory. Got it? Now see, if I don't give that increment, see what happens, it writes in the same location. It reads from this memory and it writes to the same location, overwriting. See now what will happen, it will change to 3. See, this is something that we do not want. So that is why I gave this increment, so that you see what happens when I again rebuild it. Now if you see, okay, I have both this memory. So I'll say new vertical tab, I'll say new vertical tab. Okay, now you can see both the memories. So now I have to again enter the data. See, please do not assume that the data will be there forever. Every time you get out of the debugging mode, whatever data you entered will get erased. So every time you get into the debugging mode, you have to. Okay, now you see, I press this, so R0 gets 30, R1 gets 40. So this is the address location from which I'm going to start writing my data. Counter value, R2 gets 8, you see that here. So first time when I run, what is the first thing in the location data? 0, 1, that is being converted to or written to accumulator. Now what is supposed to happen? From accumulator, it should be moved to R1, which is 40. So when I run the next time, if you observe this particular location here, it would get 0, 1. See that? Do you see that? It has got 0, 1. So next time when I run, all the increment has been made, all the decrement has been made. So next time, see, from the second location, 2 has been written to the accumulator. So it has been incremented. Now you see, in the next location, instead of overwriting in the same location because of this increment R1, it has been written to the next location. So I'm going to run quickly. You can slowly observe all the changes happening. Especially the memory window. 2, if you see, you can see the data getting changed. Observe the memory window. See, after this, no matter how many times I do, 9 will not be read because my counter value is only till 8. So thus I have transferred an array of values from 30H to a new rewritten to a new location which starts from 40H. So this is how you read and write to the memory using indirect addressing. Understood? Now I'm going to teach you how to write data in the code memory itself and how to get it back from the code memory. Okay, so I'm going to say move CJNE hash 30H. Okay, sorry, not CJNE, dptr hash 30H. Okay, I'm going to say move a comma at a plus dptr. Okay, then I'm going to say increment dptr. Okay, now there in the previous example I opened the data memory and I specifically wrote the data in the data memory. Now what I'm doing is I'm adding the data as a part of my code itself. How am I doing that? Very simple. I started my code with origin 000H. Now I'm going to start my data with a different origin 30H. Now this number and this number should be the same. I cannot have 40H here and start the data from 30H. Then there will be a read mismatch. Different set of data will be written. So then what do? I say DB. DB stands for define byte. Okay, once I say define byte, I write my data here. Okay, so I have started, I'm stating my code starts from 000H. So I have written my code. Then again I am creating one more origin at 30H and I am defining this as my data, define byte. Okay, 8 bits. So these are my, so once I define all my data, it should have a preceding keyword DB calling define byte. Okay, now I say end. Okay, now I save it. I'll compile it. Okay. Okay, see, I cannot use move here because good that we got this error. I cannot use move here because move is used only when the data are being transferred from register to accumulator or accumulator to register. Since it is from code memory and I'm using DPTR, I should always use move C. Whenever you're using DPTR, you have to use either move C or move X. Move X in the case of external memory, move C in the case of internal code memory. See, now I got 0 errors, 0 warnings. Now let's go to the debug window. I don't need this memory window, so let me close them. Okay, this is my program. See now what happens when I run it for the first time. You see this DPTR register here. You won't see the DPTR register here because these are general purpose register available for all data manipulation. This DPTR register is very specifically available only for special purpose like data pointer, so it will be here. So if you say I have moved 30H to the DPTR and 30 has been moved here. See, I told you it's a 16-bit register, right? So that's why you have 0030, whereas all these things has just 00 because these are all 8-bit registers. DPTR is a 16-bit register, so that has been done. Now what I say is move A comma at A plus DPTR. Now this DPTR is pointing to which location? 30H. At 30, what do you have here? You have 1. So when I execute the next statement, you will see the accumulator content changing to 1. Do you see that? Because from the code memory, this 1 has been written here. Now I have incremented DPTR, so the DPTR value will go to 31. What is there? That will be written. Okay, it says memory access violation because I'm exceeding the code memory there. So that is why it says memory access violation. So we have to probably, I can give 10H or 20H and then continue. But whatever it is, this is how you read it from the code memory using DPTR. Okay. I hope you all understood, how to use DPTR, and indirect addressing. Now I'm going to teach you an example with CJNE, compare, jump, and not equal to. So I say move A comma hash 5H. Okay. Then what I'm going to do is I'm going to say CJNE, compare accumulator content with value 2. Okay. And jump to loop 1. Now as far as the CJNE is concerned, one operand should definitely be an accumulator and the other operand should either be an immediate data or an address location. It cannot be a register. Again, I'm telling you, as far as CJNE is concerned, one operand that needs to be compared should be accumulator. The other operand should either be a data, immediate data, or a direct address of the data. It cannot be indirect addressing or it cannot be a register. Okay, understood? So here I am comparing the accumulator content and a constant to 2. If they are not equal, I am asking it to jump to a location loop 1. Okay, so what I'll do is here I'll say decrement A. Yes, jump last. Here loop 1, I'll say increment A. So what am I telling here? Compare A and this constant 2. If they are not equal, jump to loop 1. So it will jump here and it will increment A. If they are equal, it will decrement A and I'm asking it to jump to last. Where I'm ending. So let's see the flow. I'm going to the debug window. So I'm running it step by step. A got 5. Now in the next step, I'm comparing A and constant 2. Now obviously we know they are not equal. So what it is supposed to do? So instead of executing decrement A, it should go to directly to loop 1, that is at this point, and increment A. Correct? So when I execute next, see where it jumps. See, it directly jumps to loop 1, skipping all these steps. You got it? You saw it? And then it ends. If you want, I'll show it to you again slowly. So A gets 5. I'm comparing 5 with 2. Obviously, they are not equal. So because of that, I'm asking it to jump to loop 1. So obviously, it will jump to loop 1. You see, it jumped to loop 1, skipping all these things. So now it will increment A and then end the program. In case, let's check what happens when it is equal. So I'm again comparing it with the same constant 5. I'll save it, rebuild it. I'm going to the debug window. Now you see A gets 5. Now I'm comparing the content of A with a constant 5. Now A is also 5, this is also 5, but they are both equal. So instead of jumping to loop 1, it should execute this statement, and that's what will happen. It will come to the next statement, you see. See, instead of jumping to loop 1, it came to the next statement. Now it will decrement the accumulator from 5 to 4. And here I have given sjump last because I want to avoid this. So it directly jumps to last and ends. You understood the sequence? You understood the flow? Good. Now let me help you to understand how to write a loop statement. Move R1, comma, hash 100H. Okay, simple. DJNZ R1, comma, here, end. So this is the logic behind loop. So here what I am saying, I am moving a number 100 to the register R1. I am asking this command. What does this command tell the processor? Decrement R1, compare whether it is equal to 0 or not. If it is not 0, stay here. There is nothing like you have to use here. I can also use loop, but the same label should be here. Okay, now let me do this. Move A, comma, hash 05H. So before moving this content 5 to A, I have to wait so many machine cycles. That's the delay I am creating. So I've saved it. I've rebuilt it. Let's go to the debug window. Instead of now immediately this being moved to A, see now 100H refers to FF. So that is what is happening. Now see what happens. No matter how many times I run, you can see R1 decreasing. Can you see R1 decreasing? You can see R1 decreasing, right? So it has to wait there till R1 becomes 0, 0. Only then it will come to the next statement. See, the accumulator content is still 0. And if you see the arrow mark in the program window, it is still staying in the loop. And if you can see the R1 content in the register window, it is keep on decrementing. You see that? I'm running it step by step. If you run it as a single execution, you would have got your answer now, but you will not be able to observe this effect. That's why I'm running it as a single step. You see, I'm pressing it at a very high speed. That's why it is decreasing. I can also do it slowly for you to see. See, it is remaining at the same location. So what it is doing is it is simply creating a delay. Now you see, it's slowly becoming closing to 0. Now at this point, once it becomes 0, see what happens. It will move to the next statement and 5 will be moved to the accumulator. See, it has moved to the next statement and now 5 is getting moved to the accumulator. So till this point, it is rotating in the same place. It is rotating in the same place. Understood? You got it? And the program ends. So this is how you create a delay using register decrement thing and creating a loop. Got it? Okay. In the next lecture, we'll see in detail about creating square waves using timers, interrupts, and so on. Thank you.